Welcome. In this video, we will take a look at section 3.5, working with some velocities. We'll start with the linear velocity concept. So let's look at the definition and then we'll work some examples. So the definition says if P is a point on a circle of radius r and P moves a distance of s on the circumference of the circle in an amount of time t, then the linear velocity v of P is given by the formula v equals s, which is the distance, or we could call arc length, divided by the time t. So when we consider this linear velocity concept, linear velocity is really no different than the idea of speed that we use all the time. So when I'm driving on the highway, 60 to 70 miles per hour, or if I'm walking, say, 10 meters a second, something like that, those speeds are really linear velocity speeds. And so sometimes we can work with those in terms of a trigonometry application in terms of a point moving around a circle, but it's really the same unit of measures that would be used when we're working with speed in driving a car or seeing how fast something is going in terms of a distance divided by some time. So let's consider an example with this. If a point on a circle travels 5 centimeters in 2 seconds, find the linear velocity of the point. Well, 5 centimeters would be really the distance s. 2 seconds is our time t. So we would say that the velocity v, linear velocity, is 5 centimeters per 2 seconds. Or we could just call this 2.5 centimeters a second. So we'll end with a rate as our units, centimeters per second. And that's linear velocity. Let's consider the next few examples with a distance v. We want to find the distance a distance s covered by a point moving with linear velocity v and for a time t. So if I am moving in part A with a velocity of 21 miles per hour for 20 minutes, we want to know how far we've actually traveled. So we have the velocity v and the time t. Well, you'll notice that these two do not have the same measurements. We need to convert some time measurement so that we can equate these two. We can remember that the velocity v is always going to be the distance s divided by t. And so when I'm going to actually find s, I wanted to go find s here. I can set my velocity, this is 21 miles per hour, is equal to my distance, s, divided by my time. If I think about my time, though, this is in minutes. I'd like this to be in hours if I can. One way we could write this is 20 minutes is the same thing as, well, 1/3 of an hour. That's just one way we could write that. 1/3 of an hour, we have 60 minutes in an hour, so 20 minutes is just 1/3 of an hour. And I'm just going to keep that as a fraction, 1/3 of an hour as my time. And so I'm really, again, filling in my equation v equals s over t. So to solve for s here, we can multiply here by 1/3 on both sides. And so these 1/3 will cancel out, my hours will cancel out. And here we're just going to be left with a units of miles. Hours will cancel out on the left side. 21 times 1/3 is just going to be 7 for us. And so we will have 7 miles is equal to my distance s. And this makes sense. If we're driving 21 miles per hour, we'll do 21 miles in 1 hour in 20 minutes, 1/3 of the time. We'll only have to go 7 miles. So that makes pretty good logical sense. Let's consider a second example with some of these unit conversions. If we start with a velocity, linear velocity of 10 meters per second, and we want to go that same velocity for 1.5 hours, we can consider converting this to how long or how far we've gone. So this is velocity equals s over t. Now, if I consider this meters per second first, let's just convert maybe everything to seconds. So if I considered 1.5 hours, we can convert that first to minutes. So 1 hour in 60 minutes, and 1 minute in 60 seconds. And this problem doesn't necessarily specify what speed or time unit it wants to have, so we'll just go with the seconds. If I go to multiply through with these conversions, the hours will cancel, the minutes will cancel, I'll be left with seconds. If I multiply through with 1.5, 60, and 60, that will give me 5,400 seconds. And now I can accurately work with my velocity. So the velocity is 10 meters per second. And this is going to be equal to my distance over t, which is 5,400 seconds. I can multiply on both sides by 5,400. And so I have s is equal to 5,400 seconds times 10 meters per 1 second. And if I consider those cancellations here for the seconds, I'm really just multiplying these two values, and we'll end up getting 54,000 meters for the total distance, 54,000. So regardless of what time measurement you go into, you're still going to get the same distance, 54,000 meters. It's kind of a user's choice what you would like to convert to, either to hours, minutes, or seconds to get these two time measurements on the same plane. In our next video, we'll take a look at this next concept of angular velocity. So I hope you guys stick around for the next video. Thanks for watching.